Okay, I think we're ready to get going. I wasn't expecting to stream today, but I found a little bit of time, and I thought maybe we could dive into day 11 of Advent of Code. Let's transition over to this screen here. There we go. And let's dive right in. So we were looking at the leaderboards yesterday. Let's take a look at today's calendar. I figured weekends are usually tougher than weekdays. So I was thinking, well, let's see how far I can get. And if I can't complete it today, then I can finish it tomorrow or Monday if I can't stream tomorrow. We'll see. We'll see how it goes. Yeah, this generally is tougher. So let's dive right in. Day 11, Dumbo Octopus. You enter a large cavern full of rare bioluminescent Dumbo octopuses. These are a real thing. I guess they're a real thing. Meet the Dumbo octopus. Okay, they're a real thing. They seem to not like the Christmas lights on your submarine, so you turn them off for now. There are 100 octopuses arranged neatly in a 10 by 10 grid. All right, so we're doing grid programming again. Each octopus slowly gains energy over time and flashes brightly, for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus. For example, this. The energy level of each octopus is a value between 0 and 9. And here the top left octopus has 5 and the bottom right has 6, and so on. Okay. You can model the energy levels and flashes of light in steps. During a single step, the following occurs. First, the energy of each octopus increases by 1. Then any octopus with an energy level greater than 9 flashes. Okay, greater than 9, got it. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. So now we do diagonals. All right. If this causes an octopus to have an energy level greater than 9, it also flashes. Oh, okay, so it could chain react. We could basically get a chain reaction. This process continues as long as new octopuses keep having their energy level increase beyond 9. An octopus can only flash at most once per step. Okay. Finally, any octopus that flashed during this step has its energy level set to 0 as it used all of its energy to flash. Okay, so this is key here. We can only flash once. And then after it's flashed, we can set everything back to 0. Adjacent flashes can cause octopus to flash on a step even if it begins that step with very little energy. Consider the middle octopus with 1 energy in this situation. So we got 9s all around this one guy in the middle. And after one step, he did manage to flash because those 8 9s gave him an energy. An octopus is highlighted when it flashes during a given step. Here's how the larger example above progresses. All right, and we'll take a look at that in a bit. Wow. After step 10, there have been a total of 204 flashes. Fast forwarding, here's the same configuration every 10 steps. 20, 30, 40, 50, 60, 70, 80, 90, 100. Wow. After 100 steps, there have been a total of 1,656 flashes. Given the starting energy levels of the Dumbo octopuses in your cavern, simulate 100 steps. All right, this seems straightforward. Am I missing a trick or something? All right, so this is our test input. This is our actual input. Let's copy that. Go over to the AOC website. Oh, right. We got to make sure our quick fix list is working. Mod day 10. And then put day 11. There we go, day 11. Okay. And then that should fail. And then pump fun day 11. Britland day 11. And that should succeed. And it doesn't because I keep forgetting this bang. Okay, and then run. All right, so there's day 11, and it didn't take very much time at all. Okay, so if we're going to put in our input for day 11, I can just paste it from here, right? And I also want to add the test input. Oh, I put it in source. Oops. Inputs test day 11.text. I want to grab the test input here so we can track our progress, right? So write that, move source input day 11 to inputs. Okay, so that fixes that problem. Okay, let's figure this out. Maybe we can model this as a grid again, like we did last time. I think that's a reasonable approach. We do want to grab the code. We do want to grab the code that we had to read the files in, though. And I keep forgetting how to do that. So I'm going to do the same thing I do every time and just copy paste. Grab that, change the 0 to a 1, change the input to a test. And then we're going to do a loop, right? Oh, first let's create a struct of a grid, right? These are all in a grid, right? I'm just looking for the terminology used here. Arranged neatly in a 10 by 10 grid. Okay. Oops. So grid is just going to be a vec of, I think we got away with U8s last time. We'll try that again. Width can be the U size, a height can be a U size. And then we're just going to convert the data over. So let width equals lines of 0.len. It's the same thing we did last time. Height is lines len by itself. And let mut grid is vec of U8, vec new, right? And now we want to loop over all of the lines for ln lines. And then for c in l.chars. So we're going to grab each character. And then we're going to convert that character to a U8. So grid, oh, we can just do this here. Let mut idx equals 0. We're going to start at 0, and then for grid of idx, it's going to be c as U8 minus the 0. And we got to increment grid. Increments the index by 1. All right, so that should give us a grid that we can print out. Right? Let's actually draw that. Impl and draw that. Grid, we'll print that out using a function here. We'll just call it print self for x in 0.width. Oh no, we want to do y's first, right? We do y's first. Self height for x in 0.self width. And we're going to do index again. Print bang this and just printing out the self grid of the index and index plus equals 1. And that's it. Oh, then after each row we have to put in a new line. So, right? And now I should be able to say let mut grid. It doesn't have to be mutable yet, but it will be. I'm just thinking ahead here. Grid octos is equal to a new grid of grid width and height. And I should just be able to say octos.print. Right? And that'll give us our. It panicked. Len is 0, but the index is 0. Oh, I have to push. So we don't need this. I made a mistake here. So what we're doing when we're building the vector, we want to push the characters on. We don't need that. And then it was also complaining about, oh, y and x are not used. Yeah, that's true. So we can just make those underscores. All right, let's try running that. That looks like it worked, right? I see 1526 at the bottom and 5483 at the top there. Okay. So I think we read the grid incorrectly. Read in the grid correctly is a better way to phrase it. So now we need to write a step function, right? So we write a function which does one step of the octopusing, the flashing. So how does the step function work? It takes itself, and what do we need to know? Okay, what's the thing looking for? How many total flashes are there after 100 steps? Oh, right. So after 100, so let's return how many flashed for this step, and then we can just sum them up, right? That should be relatively easy to do. So we just need to do these 3 steps, right? The energy level of each octopus increases by 1, so we just loop over each one and add 1. Then any octopus with an energy level greater than 9 flashes. Okay. So how are we going to model this? We can use, like we used a stack yesterday. We can use a stack again. Was it yesterday or the day before we used a stack? Just to keep track of which ones are flashing, and then we can loop over everything that flashes. So let's create a stack of the octopuses that are flashing. And how do we want to store this? We do need to do all the adjacent, the 8 adjacent guys around it. So let's store this as XY coordinates using I32s. I think might be the easiest way to do it. And then we can create a const dirs, I guess, which is just going to be a list of 8 tuples that allow us to just loop over them. Right, so this will be 8 tuples. I32, 8, right? Is that the syntax for this? Equals, and then we're just going to make, let's say, let's go clockwise starting from north. So north is 0 to the x value, -1 on y. Northeast is going to be 1 on the x value, -1 on y. East is going to be 1 to x and 0 to y. And then southeast is 1 on x and 1 on y. South directly is 0 on x and 1 on y. Southwest is going to be -1 to x and 1 to y. And then west is -1 on x and 0 on y. And then finally northwest is -1 on both. So I'm sure Cargo format will reformat that for us. You can probably stretch it all out. So, okay, so these are the cardinal directions. Not cardinal directions. These are the 8 directions. North, northeast, east, southeast, south, southwest, west, northwest. Right? And then we can just loop over those in our... well, first we have to see which ones are going to flash, right? So we need to say for I in 0 ... self grid len. Now this is a 10 by 10, and the test input is also 10 by 10, but I'm still making it generic. Self grid of I plus equals 1, right? So every energy level goes up by 1, and then if its grid of I is greater than 9, right? Any energy level greater than 9 flashes. So what we're going to do is push. Let's make a little function. Call it xy. And give it an idx. So we're going to convert an index into a tuple. And all we need to do is say index divided by width. Mod width. as I32 and IDX divided by self-width as I32, and that converts it from a index into a width, into an XY, because that's what we want to push. We want to say flashers push of I, right? So what this is going to do now is create a list of every octopus that's going to flash on this step, and now we have to take care of the propagation. So we're going to loop over this flashers array, but we're going to also add on to it because other octopuses could flash while we're flashing our current one. We could end up actually making another octopus flash because we're going to flash all the surrounding. So instead of doing a for loop, we're going to do a while loop, right? While the flashers is not empty, right? Then we're going to destructure, we're going to pop and destructure the tuple to get our XY coordinates from the stack, unwrap. And then now we have an XY of an octopus that's going to flash. We're going to use that DIRS array, and we're going to loop over those. Do I need to ampersand that? Probably not. I don't know. I don't know Rust well enough to know that needs an ampersand to borrow it. It should be fine, right? Because it's just a constant. It's a static. We're not modifying it. Let's see if this works. This is the bottom line. So then we're going to find the location of the octopus that we're spreading our energy to. So location of X and location of Y is equal to X plus D0 and Y plus D1, right? So what we're going to do is add 0 for the first loop. Time to the loop, we're going to add 0 to X and -1 to Y, right? And then so on. We'll add that and that and that and that. So now we have the XY coordinates of an octopus that is going to get a boost to its energy level. And now I want to convert that to an index, right? Because I want to say if self grid index is less than 9, no, less than or equal to 9, because we do greater than 9 here. If it's less than or equal to 9, then do something. So we need to convert the index, the XY, into an index. Self X I32, Y I32, and that gives a U size back. And that's pretty easy to write. It's just Y times self width plus X, all as U size. Right? So, oh yeah, but we don't want to go off the grid, right? If we're on the top row, we don't want to subtract 1 from Y here. So why don't we have this return an option of a U size, and then say if X is less than 0 or Y is less than 0 or X is greater than self width or Y is greater than self width, then return none. Otherwise, we don't have to say return. We just do this and then else sum this, right? Yes. So this will convert the index into an it'll convert an XY into an option index. So we can say down here now, if let sum index equals self.idx of X and Y, LX and LY. That would have been a bad mistake to make. So that means if we have an index on the grid, then we can do this. And what are we going to do? If it's less than or equal to 9, right, we're going to increment it. Because if it's greater than 9, we've already hit a flash here, right? So we're just going to increment it by 1. And now Now that we've incremented it, if it's greater than 9 at this point, then we're just going to add it to our flashers array. Our flashers, and it's LX and LY that we want to add. Right. Just looking at my music here, it sounds like we're playing the same song over and over again. I'm going to switch to a different song and see what happens. Okay. Diversion. I'm not doing Advent of Code for speed. Okay. Let's see. So then, right? So I think we took care of this middle paragraph, right? An octopus can only flash at most once per step, right? So we're only going to add it if it only bumps up over 9 here or here. But we don't reset it to 0 yet. We have to reset it to 0 here. And, oh, you know what I forgot? We need to keep track of how many are flashing. Let mut flashed 0. And then what we'll do is we'll count it. We can either count it when we push or we count it when we pop, and we only pop in one place. So that's the easiest place to increment it. So every time we pop something off the list here, that means an octopus flashed, and we can return down here flashed. But before we return, we have to reset all of the octopuses to 0, which I think is pretty straightforward, right? For I in 0 dot self grid len, if self grid of I is greater than 9, so any octopus that flashed this turn gets reset to 0, right? I think that's all of a single step, right? So what we can do is we can just try this with our test input here and see if we get. So we'll print it out. We'll do a step. And let's actually, what we can do is println that at 1 step. And it should be no flashing. Right? I don't see any flashing in here. After step 2, there's some flashing. So let's see. Let's see what we get. Print. We'll do it again. 2 steps. Just line them up. And then print it again. Oops. Like that. All right. Will this even compile? It will not. Oh, right. All of these have to be converted between I32s and U sizes. Yeah, that's that one. Oh, yeah, as I32. That's it. Okay, what are we doing here? Oh, it's not mutable. Okay. All right. Let's see what happens when we run it. It panics. Line 76. Let's fix the panic before we look at the output. It looks like we're going over the index by 3, which means that this didn't work. Oh, duh. It's got to be greater than or equal to. All right, let's try again. All right, so it didn't panic this time. Let's see what happened. We have 6594, 6594 at the top, 2637, 2637 here. Yep. And then does this one have, it does have a bunch of zeros. Of course, I didn't highlight any of them, but it kind of looks right. 87 and then 4 zeros and 6848. So I think it's working. Let's do a quick test with the test input and see if we get 204 flashes after 10 loops. That would be the next thing to do. So we're going to say for, we don't care about the variable in 0 to 10. We're going to say octos dot step. Oh, and we need a sum let total flashes equal 0. And then we'll just say total flashes is that. And then say println after 10 steps, we have total flashes. And let's hope that that's 204. And I forgot the bang. I'm going to pull this thing up again. There's music. All right, we'll just keep an eye on the music. Okay, let's run again. And there I hit F1 again. Okay, stop that. Run again. Print is not being used, but that's okay. After 10 steps, we have 29, so we have a bug. Oh, yeah, because it's supposed to be plus equals. All right, that's an easy bug to fix. 204. Okay, good. And then after 100, it should be 1656. So let's try 100. $16.56. So this is day 11, part 1. Is this, right? Because it says how many total flashes is there on your actual data after 100 steps. So let's change our input to this. I think that's what I called it. Nope. Oh, test input day 11. Oh, I didn't save it? Oh, input day 11. Okay. Okay, one more try. 1686. Well, I mean, why not? All right, that's the right answer. That's good news. Okay, let us check this in. Oh, I do want to get rid of the print. I don't think we need it anymore. I'll just comment it out for now, and then I'll remove it when we do part 2. Hopefully we won't need it for part 2. I don't know what part 2 would be. I mean, maybe it's navigate your way through the flashing and from like upper left to lower right, and don't be on a square where it's flashing when you get there. That would be a kind of a crazy thing. Right, git status, git add input and source. Oh, Clippy. Oh, are we still in this thing? No, we're not. Okay. Clippy. Oh, we're not using height anywhere. Really? I guess not. I guess we never need it. Oh. Yeah, because we don't get the grid len anywhere. We set height, but we never use it. We don't, instead of doing like width times height here, I just say grid len, right? That's easy enough, and I do the same thing here. So we don't actually need to know the height of the grid. Okay, sure. Let's get rid of height. And then where do I create the grid? Here it is. It got spread out. That's why I missed it. I was looking for a single line. Okay. Does that still check? It does. And is Clippy okay? Clippy's fine. All right. Git add source. Git commit -m. Day 11 part 1. All right. That went pretty quickly. Let me go back here. I'm not going to bother looking. Okay. Next. So let us take a look at what part 2 has for us. It seems like the individual fishes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. Okay. In the example above, the first time all octopuses flash simultaneously is step 195. Oh, I see. They just end up at all zeros. I guess at that point, then they just flash on and off. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Oh. Well, okay. I mean, that's just looping until octos.step can return the width times the height, or the grid length. We don't have the height anymore, right? I mean, is that it? So I'll just say let all flash is grid.len. And then we keep looping. We just say loop. We keep looping until we hit all flash. But what if we hit... Yeah, I'm just trying to think, how can we do both part 1 and part 2 at the same time? And maybe the easiest way is part 1 done is false, part 2 done is false, and then just loop while not part 1 done or not part 2 done, right? We want to keep looping while either one of those is false, and just say, we want to keep track of how many flashes. Let steps equals 0. So what we'll do is say if steps is less than 100, total, let flash count equals octos dot step. If steps is less than 100, then total flashes plus equals flash count. And else part 1 done is true. That's going to set every time, but I don't care. I don't care. And then we want to say if flash count equals all flash, then we want to save the steps that we want to save the steps that we got that point on when they all flashed. We'll just say part 2 equals 0. And we'll call this, instead of 12 flash, we'll say just part 1. And call this part 1. And then we can get rid of all of this, and we'll just say, here we'll just say part 2 is equal to steps, and then part 2 done is true. That way, if part 2 finishes before part 1, we can catch it. And if part 2 finishes after part 1, we can still catch it. So this changes to a 2. This is part 2. And this is part 1. This is probably over-engineered and under-engineered at the same time because I'm setting this every time through the loop. But like I said, I don't care. Does that check? It doesn't check. Move occurs because grid has type something, which does not implement... Oh, grid, it's octos grid length. There. And we still got 2 warnings, though. What are we not doing? Oh, I'm not incrementing steps. See, that's why, thank you, Rust, for doing that. And then we'll just say steps plus equals 1. Okay, now it's there. Let's run. You know what? Let's run it with the test input to make sure. Let's do that first. Because what do we get for the test input? It's 195, and this is 194. Okay, perfect. And 1656 is correct, but I got 194 for the steps. So maybe I just put this up here, but then this is going to be wrong, right? We have to say less than or equal to 100, sorry. So 1656 and 195. Yes, okay, so now let's run it with the actual input. There. 360. Okay. That's the right answer. Wow. Okay. So that was easier than I thought it would be. That took less than 40 minutes to do, and some of that was rambling. So that was a quick stream. Let me clean this up. We don't need the print function anymore. So delete all this. So we have an XY. I'm just going to comment. Convert index to XY coord. And this is convert XY coord to index. Make one step of the problem. Do one step of the problem. All right, so this is going to say find all OCTOPUS which will flash this turn. Find any octopuses triggered by the above flashers, and then set any flashed octopuses to 0. All right. I mean, that was pretty easy for a Saturday puzzle. So, I mean, the last few puzzles have been pretty easy. Let's see what the leaderboards look like. My personal stats a little bit better than yesterday. And then what do we got in terms of private leaderboards? I'm number 4 now. Yay. On Chael, where am I? Down here on 11. Not even in the top 10. This is a big list. Where am I? There I am, 34. Wow. And on Togglebit, I am... Oh, I'm in 7th position now. Okay, and then now, did he do it today? He did not. Okay. All right, that was fun. That was a lot of fun. Let me git add source. Git oh, did I do Clippy? I did Clippy right there. Git push. Oh, git commit day 11 part 2. And there we go. Okay, that was easy. Unfortunately, that's all the time I have for today. I will hopefully stream tomorrow with day 12. We'll see. But meanwhile, thanks for hanging out with me, and I hope you have a great day. Take care.